Are you having trouble in Mr. P's class? Maybe not even paying attention? Even failed the test? Well, we are here to help. This example is for solving complex circuits. We have a circuit with a 10-volt battery, a resistor with 330, a resistor with 470, another resistor with 330 and 470, two with 1K ohms, and then the last resistor has 10K ohms.
To find the total resistance in the circuit, you want to simplify the whole circuit into a simple series circuit. So starting from the opposite side of the battery, we notice that R5, 6, and 7 are in a series circuit. We can combine them using the formula R1 plus R2 plus R3 equals total resistance. So let's calculate that. 1K plus 1K plus 10K equals 12K. Let's redraw the circuit. Now that we've redrawn the circuit, we can see that R3, R4, and the one we've just created are in a parallel circuit. Using the parallel resistance formula, which is 1 over R1 plus 1 over R2 plus 1 over R3 equals 1 over total resistance, we can calculate the resistance. So 1 over 330, 1 over 470, 1 over 12 equals 190.8, which rounds up to 191 ohms. Let's redraw the simplified circuit. Now we can see with our simplified circuit that it's a simple series circuit. Using the series formula for resistance, which is R1 plus R2 plus R3, we can calculate this. So 330 plus 470 plus 191 equals 991 ohms. Now we have the total resistance of the entire circuit right here. Using the voltage and the total resistance, we can find the current of the circuit. Total current. So V equals IR. Voltage is 10, resistance is 991, and current is unknown. So using formula, we can figure out 10 over 991 equals 0.01 amperes. That's the total current of the circuit. Okay, now since we found the total current, we can find the resistance across R1 and R2. Because in a series circuit, current stays the same. So let's find the voltage across this. V equals IR. So the current is 0.01 and the resistance is 330. That equals 3.3 voltage. And for this one, V equals IR, 0.01 times this resistance, which is 470, that equals 4.7 volts. Okay, now let's start keeping track of this. Voltage across R1 equals 3.3 volts. Voltage across R2 equals 4.7 volts. And voltage across R3 equals V equals I R, 0.01 times 191, which is 1.9 volts. Now let's re-expand this part to find the voltage across all of them. Okay, now we can find the voltage across resistance 3. So in a parallel circuit, voltage stays the same. So the total voltage for this one was 1.19. So 1.19, 1.19, 1.91. Whoops. Okay, so if the voltage for this branch is just 1.19 volts, resistance 3, the voltage is 1.91. Okay, same for resistance 4 as well. Now it starts to get tricky with the last branch. So let's combine this again. So now let's combine these. So now let's redraw that. 1.591 amperes. Now with the simplified form, we can find the total current of this strand. So V equals IR. So our voltage is 1.91 equals current, which is our unknown, times 12K resistance. X equals 0.000159 amperes. Let's re-expand the circuit and find the individual resistance voltage across each of the resistors. Alright, now since we know the total current is 0.000159 amperes, we can find the individual voltage. So using V equals IR for resistance number 6, let's calculate that. So voltage is our unknown. Current is 0.000159 times 1K, which equals 0.159 voltage. So resistance 6 is 0.159 volts, and since this has the same resistance, resistance 5 is also 0.159 volts. Now let's calculate resistance 7. So V equals IR, voltage is our unknown, 0.000159 is our current times 10K, which gives us 1.59 voltage. So for resistance 7, our voltage across it is 1.59 volts.
Now to find the current of R1, we just simply plug in the voltage and the resistance into Ohm's law. So it'd be 3.3 over 330 ohms, which equals 0.011 amperes. For R2, we do the same thing, but with different numbers. So it would be 4.7 volts over 470 ohms, which equals 0.1 amperes. And we do the same thing for resistor 3. So since it has the same resistance value, but a different voltage, we plug in a different voltage, so 1.91 over 330 equals 0.005 amperes. Now, to find the current of resistor 4, we simply just put in 1.91 volts over 470 ohms equals 0.004. Now for 5, we put 0.159 volts divided by 1K, which equals 0.00159 amperes. For 6, we simply just put 1K, which is divided by the voltage, 0.159, which is the same as R5, which is 0.00159 amperes. Now for R7, we simply just put 10K ohms, which is divided by the voltage, 1.59 volts, which equals 0.000159 amperes.
Okay, because R5, R6, and R7 were in a series circuit, they all have the same current, so we didn't really have to calculate R6 and 7. And hope you don't fail the next test. Bye!